Hello everyone. In this video, I'll be walking you through the whole code of Telugu handwritten text recognition system, which we trained using the Vision Transformer architecture. We'll go step by step from the folder structure. This is the main folder, which contains the whole code of the project, including the front end, back end, and the model training modules. So coming to the Vision Transformer Telugu H100 IPYNB file, this is the major code where the trading module code will be contained of the whole system, and the testing VIT file will contain the testing code of the Telugu HTR model, and this file consists of the saved model weights of the trained Telugu transformer model for HTR task, and followed by this run.py file contains the initialization of Flask application of the whole front end and back end service of the application. After that, requirements.txt file contains the whole requirements of the application. Followed by that, the application folder contains the front end and back end code of the application. Let's dig into the model training phase. Here, we will install all the necessary libraries in order to train our model. After that, we will download the dataset, which is publicly available AAA handwritten Telugu dataset. Along with that, we personally combine the custom dataset prepared by us, which was provided by our professor, which is of page level, and we converted that into word level and prepared a custom dataset. We combined both publicly available AAA dataset and a custom dataset in order to train a transformer model. So before digging right into the code, here, as you can see, we use NVIDIA H100 PCIe hardware system in order to train our model efficiently. Thus, such complex system would help us to train our model fastly and efficiently. Okay, let's dive into the code. We import all the necessary libraries and everything. After that, we will begin by importing the training, data loading, and image processing libraries, and then we define the feature extractor, which is the base model we want to use. This will reside all of the images into 225 by 224 pixels, and then so make them suitable tensors for the VIT model. After that, we dig into the Telugu dataset class. Each line of the file of the label file contains image path and its label separated by a space, and images are loaded using PIL library and then passed through a VIT feature extractor where they return the pixel values as tensors and the label string. This setup ensures all the images are processed in the same format used by the model, which is pre-trained VIT patch 16. And then followed by that, we will create train test and validation datasets separately in order to make sure we follow the machine learning principles. And then we will dig into the label encoding phase. To convert string labels into integers, we use sklearn's label encoder library. And first we combine all the labels from the dataset, and then we fit the encoder and transformer labels into the numerical format to make sure the model will predict using those numbers as an output layer. And then after that, we will use we will encode Telugu dataset to our model. We create wrapper class, a wrapper dataset that replaces text labels with the encoded integer labels. This class ensures the images from the original dataset and returns them along with encoded labels. And then after that, we use data loaders. Here, we use high batch size of 128 to utilize the memory of H100 GPU, and then we also use shuffle equal to true for false for the validation and test datasets. Followed by that, we will define our model, uh, and then we set num labels to the total number of Telugu word classes and allow the classification head to be adjusted. After that, we dive into the training configuration. Here, we will define cross entropy loss, which is ideal for multi-class classification in such kind of cases. And then we will define an Adam W optimizer with a learning rate of 1 e to the power of -4, which is very efficient for the transformers. And also we use the schedulers cosine annealing learning rate or LR gradually lowers the running rate over the 50 epochs which we want a transformer model to be trained on. And then after that we enable we enable TF32 and AMP for better speed and performance on H100. Here you can see that. After that, we also use amp.grad scaler to safely use float 16 precision and not to miss any kind of precision problem errors. After that, we use accumulation steps equal to 4 to simulate a larger batch size and stabilize training. And then we dig into the training loop. Here, if you can see, we set the model on to training mode, and then for each batch, emails and labels are moved to GPU. We use autocast for mixed precision here, as you can see here. And then we accumulate gradients and update weights for every 4 steps. After that, after each epoch, we step the scheduler and log training loss and learning rate also. Here you can see that. And then we validate the model after each epoch here, and model is switched to evaluation mode before that, and then we run inference on the validation set, and then we will print the validation accuracy and the loss computed over the epoch. And then after that, once we successfully train the model, we will save the model after all the 50 epochs are trained. And we will say after saving that, we will be using that saved model for inference tasks. Finally, the evaluation. In order to do that, we need to go for the testing VIT phase. Here, if you can see, we use the same architecture in order to predict the input image. So if you can see here, we have predicted over 200 images, and those 200 images have been got from the test dataset, and out of them we've got over 70% of accuracy, where 143 of them are completely correct in predicting the output. And this wraps up the training pipeline of the whole Telugu HDR system. In this way, we have trained the whole model on the NVIDIA H100 GPU and successfully achieved the results of 68.05 accuracy on the after training 50 epochs successfully. If you can see here, so this is the training output, and the code combines the power of transformers with efficient training techniques like AMP, gradient accumulation, cosine annealing learning rate, and all optimized cross entropy loss, etc., etc., and also which are optimized for high performance GPUs like H100. Without further ado, we can directly use the saved Telugu VIT model weights in order to predict and inference tasks. Yeah, that's it. That is what Telugu HDR system we have developed. Thank you.